Hello, everyone. Good morning. It is great to see so many of you back. So, I'm super excited to have you today. This is, I believe, our fourth rendition of this webinar that we have here at Tombolo Research. It's a bi monthly webinar that we have every month. Our first one was all about let's talk about AI. Then we moved into agentic AI. And the last time we met was for ethics and robotics. And then everyone's favorite talk was with Hannah. We had that just about 2 weeks ago. Actually, this makes this our fifth rendition, actually. So we're growing, we're building. Exciting to see. So thank you all to so many people that came back. So hello to Angela. Thank you for coming back, my sweetie. And Ali saying that this is one of his favorite topics and he still knows almost nothing about it. Really funny. So I'm glad to see you here and you're super excited to learn. Me too. Yes, the audio was, I had a little audio issue in the beginning, but all sorted now. You all should be able to hear me perfectly now. Perfect. So, today's topic, let's talk about world models. I'm not going to go too much into it yet because I don't want to reveal the surprise. But if you know about it and if you've seen it before, let me know in the chat what you've seen already. So, have you heard about world models? Have you seen any examples? It's been popping up a lot on the news lately. Actually, quite a few people have been talking about it. It's not big yet, but if you're in the AI space, then you've definitely heard about it. And if not, don't worry, that's why you're here to learn with us all. So before we hop in, I wanted to say a huge thank you to Hannah Klaus. She was our guest just about 2 weeks ago, and everyone loved it. The comment section was blowing up. I could barely even finish the webinar. That's how many questions you guys had for her. So of course, we have to do a part two. So Hannah, I know that you're super busy, but the people need more. The people are waiting for you to come back. So we're gonna have to do a part two of Hannah when she's not too busy, because as you know, Hannah is a PhD candidate at the University of Cambridge, so her schedule is like swamped. So the next time we can get her, we'll definitely have her back, hopefully in like April or May. Have to coordinate on that to see when she'll be around. Did any of you join that one? Wasn't that such a great session? Ah, Sweetie says, yes, Hannah was great. Looking forward to learning too. Yes, me too. And I have to pause. Usually I take this time to ask questions that you had from the previous webinar, but from the last one, I know that there's going to be a lot of them, so I won't have much time to do that in today's session. But I wanted to say a huge thank you to the people that are joining me on the webinars, whether you're joining me before, during, or even after to watch them. I really appreciate you. And the numbers are even bigger than I expected. But I haven't actually been monitoring the analytics nearly as much as I usually would. But then I looked today and I was like, oh my goodness. So there are 250 of you on LinkedIn following along with us and watching almost every episode. 50 of you on YouTube. And of course, if you want to join us and help us to grow that number, you have to register on tomboloresearch.ai for the next webinar. And I look forward to seeing you there. So thank you so much to the 250 of you on LinkedIn. I had no idea there were so many of you. And then of course over on YouTube, thank you, but we can pull it up, the YouTube people. So looking forward to seeing you for today's webinar, and then of course for all the other webinars that we have coming up. And if you want to register for the next one, you can. But if you missed the previous ones, you can also head to the website tomboloresearch.ai to check out the ones that you might have missed. Woohoo! Gotta keep an eye on the LinkedIn chat comments. So if you're commenting on LinkedIn, forgive me if it takes me a minute to respond to you. It just takes a little minute to load for some reason. Still figuring that out. Oh goodness. Hopefully it doesn't make any noise. Okay. I'll be keeping an eye on it, so feel free to comment away. And also before we move on, we need your help. So here at Tombolo Research, we are all about ethical, doing ethics, making sure that we are held accountable, making sure that you fully understand what we're working on and also like how we're going to be using things. And now we need your help. So we've been talking about AI ethics and collecting data responsibly, and that's what we want to be able to do now. So stay tuned. On this week's Saturday, I'll be announcing a project that we're working on. So it's not the full robot yet. If you know, Tombolo Research is launching a robot product this summer. I can't tell you what it is, but I can give you a little sneak peek if you help me by joining us on Saturday. We'll be doing a little bit of data collection. There'll be video data. I have a funny story actually. The last time that I did a data collection was when I was about 16, I think. I did a genetic study in Bermuda. It was really big. We had about 400 participants overall, but of course that was my first time. And I was very new to it, and I was just like, super excited. very nerd, very much like, oh my goodness, I'm doing science and everyone's going to be as excited as I am. They were not. I was going around and asking people. I was just going up to them, and my mom was with me, of course. She was the huge catalyst for helping me to get so many people. And sweetie, if you're listening, you have to help me again this time. But when I went up to people, I'd be like, "Are you excited to do my genetic study?" And they're like, "Ugh, genetics." So I promise. Last time it was all like cheek swabs and doing a lot of like very much more, I guess, how to explain, like health, like cheek to cheek kind of data. But this time it's not as invasive. So I'm excited to do this one. I just wanted to share that funny little story. If my mom is watching, she can she can share a little bit more. But yeah, island-wide attention, because what happened was, to tell you the whole story, my mom posted about it on Facebook. And of course, because she's very much a popular person, everyone that saw it was like, oh my goodness, Angela's daughter? Where we meeting? Where we going? So I think it was, gee, what street was that? Where they were like lined up around the block to come to the study. So I'm hoping that you all will do that for me again for this one, so that we can like meet up and try to, oh yes, the gym experience. You can tell my mom was in the comments with me. So yeah, the gym experience, it was really funny. Basically we wanted to do as many people as possible, but what I noticed was, which is actually quite common, especially in the Black community, we have this fear and distrust around any kind of health related data, because our data has been misused and abused in the past. So one of the places that we went to try to like break the stigma was the gym, and we were going there. Thank you, sweetie, Cedar Avenue for the street. So we went to the gym to be able to, meet people where they are and make sure if they were comfortable. We were able to do a lot of data collection there. So this time, I can't share too much. I'll tell you all about it on Saturday. But this time, we're coming for video data. I will see you on Saturday when I announce the full thing. But in the meantime, I was just hoping you would stay tuned and look out for when we have the announcement on how we're going to be collecting data and how, of course, you can get involved. This is the first time that Tombolo Research is kind of giving you a little sneak peek as to what we're working on for this robot project. So I hope you're looking forward to it, and I will see you on Saturday. Okay, let's dive right into today's topic. So when you look at today's AI landscape, it seems like there's about three, maybe four or five, but like these are the three main giants in AI. If you don't recognize these logos, I mean, I feel like everyone almost does, but if you don't, the first one is OpenAI. Then in the middle, we have Anthropic. And then on the side, we have Google. So there's ChatGPT, Claude, and Gemini. So if you already know about AI, you're going to know that these are the top three models almost everybody is working with and using in their projects. And that's kind of been like the, I guess, be all and end all of AI. Every project seems to be very LLM focused, or they're using like different visuals, and it's all kind of a wrapper of the same thing. Everybody's using LLMs, everybody's using computer vision models. But there's something a little bit different that I want to talk about today. But these are the big three. If you haven't already seen them, these are the big three.
Santiago always tries to finish my sentences and frequently gets it wrong.
I do not, and I am not wrong.
You do it all the
time.
No, I was going to say all the day long. See? Frequently wrong.
So I love Brooklyn Nine-Nine. If anybody else loves the show, let me know. But in this scene, you see Amy and Captain Holt are upset at each other because Amy always tries to finish his sentences, but technically gets them wrong, like usually gets them wrong. And I made this little meme because I thought it'd be really funny to explain how LLMs work. So LLMs, if we go to the next slide, are basically these predictive models. So what they do is they take in a lot of training data. In the case of things like ChatGPT, Claude, Gemini, it'd be like internet scale kind of data. Like, can you imagine how much data is on the internet right now? Imagine all of that in one model for training. And that's what happens. Then they're able to tokenize that data, give it some kind of context, and then the LLM is able to generate text. But the way that it does that is it tries to predict what your next word would be. So for example, if I said the, it will have like, a huge list of words that'll be like maybe the cat, the door, like trying to predict what I'm going to say next. And in the beginning, when they were first starting out, it would be frequently wrong, hence the meme I made from before. But this is how they work. They try to predict your next word, and they try to like generate text that they think would be most what you want to hear. Which, as I'm saying it out loud, I'm hoping that that's putting off a couple of alarm bells for you, that it's predicting what you want to hear, and it's predicting based on your user data, the internet scale kind of data, and then giving you that text. That's how these LLMs are really working. Ali says, I love the show, and this was hilarious. Yeah, me too. It always gets me. I'll have more Brooklyn Nine-Nine memes later. So what are they good at? These LLMs are great at writing and summarizing. They're great at, oh, I have my clicker today and I completely forgot about it. So they're great at writing and summarizing, explaining concepts and tutoring. So for example, if you're a student and you want to learn something, you can use an LLM to help teach you because you can ask it like, explain this to me like I'm 5 years old, or explain this to me like my university professor, but in a simple way. There's ways that you can help teach yourself, or writing and summarizing emails and things like that. Nowadays, you have things that can actually review your code for you. So this is a really big one and really exciting. For example, if you've heard of things like Cursor or Claude Code, now we have this new one called OpenClaw. This is a lot of different ones that are working on this generating and reviewing of code. And this is all LLM based, of course. And they can act as a natural language interface to different tools. Definitely one of my favorite shows. So this is one of the ways that you can interact with these LLMs. So what I really like about them, everybody loves them. I'm not gonna say that they're like super terrible or anything. Like the tool is great, but it has its limitations, right? Something's missing. So it doesn't have everything that we're looking for. For example, the memory is lacking. How many times have you spoken to ChatGPT? You go for a long time and you're talking, and then you notice it's forgetting things. Like maybe at the beginning you told it, hey, remember that I am doing XYZ in my business, or remember that I want your help with this subject. You start to notice that, it's forgetting what you said. Like it won't be able to remember it, and it feels like you're just repeating yourself. If you've ever had that experience, that's why I have like the cat memes, like, huh? What's going on? That's kind of how it feels when the memory of these AI is just not where it needs to be. Like it just doesn't remember stuff. And then just because the AI is fluent in English, for example, doesn't mean it's understanding you. So just because it's like, you feel like you're in that flow state with it, you're going and you're asking it questions and you're saying like, hey, I need you to help me with this. And it's like, I got you, Cameron. It gives you out the answers that you're looking for. You're like, wow, this thing is great. Like, we're in the flow state together. We're moving, we're going. But does that mean that it understands you? Not necessarily. Then there's hallucinations. So if anybody else is a Sailor Moon fan, or if you've probably seen this meme before, it's like LLMs, is this reasoning? And no, it's just a hallucination. So there's tons of hallucinations that occur as well. So you'll be talking to it like, okay, so who is Cameron Young? And maybe it'll tell you that I'm 50 years old and live in like Argentina or something. I don't know. It can hallucinate about these random things because the data that it's trained on is set to a specific time. So remember I mentioned that these LLMs are trained on internet scale data. So for example, when you look at them, so like you have ChatGPT like 3, 4, now 5, each of those is trained on a certain timeline in the internet. So if you ask it questions about things that are outside of that timeline, it's not going to have any context. It's not going to be able to understand what you're saying. But remember I said that they're all about predicting your next word and trying to give you what you want. It's not going to tell you like, I don't know that actually, I'm not really sure. It's going to say, I got you. And it's going to give you something, anything, just so that it gives you an answer. But that may not necessarily be correct. This is a big thing, especially for students, because we're trying to use it for helping us to learn, helping us to study. And if it doesn't know something, it's just going to tell you what it thinks, but it won't necessarily be correct. This is a big thing as well, paying attention to, double checking what it's saying and checking on the information that it's giving you. Okay, let me go back to the chat here. I finished my little slide. So Kick says, yes, so frustrating. Yes, the memory thing is really frustrating. And Ali says it always happens when using ChatGPT, and when using it to build a project, it becomes problematic because it forgets the structure of the project. Yeah, exactly. So if it's too long of a chat, it's going to forget it, and then you have to restart over again. It's just a huge mess. Shay says, when switching from a long thread to a new one, I asked, do you remember what we last spoke? And it's like I'm talking to someone with dementia. That's funny. Because it always forgets things. It doesn't really keep that context for a very long time. So just checking on the LinkedIn people to make sure I'm not missing anything. Okay, we're good here. Don't see anybody in there. Okay, cool. So what's the issue? Like, why does it have these problems? Why do we keep seeing the same mistakes? Like, when did ChatGPT come out? 2022? November 2022. I actually checked before this talk. So it's been a while, but these problems are still the same. They're still an issue for us. Like, the memory, the hallucination, not really understanding the context. Why is this still an issue and why hasn't it been solved? Well, they're trained to sound plausible, not necessarily to be correct. Remember, I said they're just training on huge amounts of data and doing prediction as to what the next word should be. So they're not necessarily thinking, okay, wait, if Cameron's asking me about, the next step in her startup or the next step for this robot piece, like I don't necessarily need to be correct. I just need to think what's most likely to be the next step. Like it's not trying to check it for me. And it needs external tools to be able to do that, to be able to track the world. So who else remembers when Claude and ChatGPT started adding in like search the web? So now when you search with them, you can actually be searching the internet at the same time. And that's supposed to help a little bit with the hallucination. But then of course it introduces other privacy things, because as you're using it and connecting to the internet, technically it's giving that context to the internet as it's searching for you. So it's a lot of like a bit of an up and down kind of situation, I think. And there's no grounding in the real world. So as it's giving you these predictions, there's no grounding in the real world. So it's not really saying, oh yeah, I can tell you about this because I've experienced it myself. Because obviously it's an AI, it's a software, it's a model. It's not going to be able to run around outside the way that we do. So it doesn't have that real world experience that we do. Shay says that they learned how to use and speak language really well. Yeah, exactly. So they speak it really well. So again, fluency does not equal understanding. And that's kind of the big thing with AI. Well, LLMs in particular, actually. And again, they have no built-in memory of any objects, locations, or timelines. It's all dependent on what data set did you give it to train on. So as I mentioned before, a lot of the bigger models are trained on the internet, for example. And if they're only training on, internet from, maybe the beginning of time to 2022, then anything that happens after that, even a day after that, it's not going to know. It's not going to understand. It just doesn't have that context. And updating it and doing all of that takes a lot of time, compute, electricity, money. It's expensive to be able to do all of these things. So not many companies are going to update it all the time. They're just going to say, hey, add this external tool, and it'll be able to tell you these things. So it doesn't actually have a built-in memory about objects, locations, and timelines. Okay, let's take a pause, a little bit of a break. And okay, imagine yourself on this street. You're about to cross it, and many things will pop into your mind. You want to be safe, avoid people. There's a lot of people here. If anybody else is an anime fan and recognizes this area, please put it in the chat if you recognize where this is, because I really want to travel here. If you've traveled here, I'm very jealous. I want to go here one day. But so picture it. You're trying to cross a very busy street. You're thinking about, who's next to me? Is there a car coming? How long do I have to cross the street? It's like my bag is kind of heavy. I want to get across really quickly. All of these things are going to automatically pop up in your mind because you have that context. You've crossed the street before. You know what's going on around you. Like, you're holding objects. You know that there's people around you. You have that context. You have that understanding. And then, oh, sorry, I see a little chat here. He says, as much as I love GPT and its capabilities from launch till date, so far they have pushed for upgrading and pushing for newer and better features. And I feel as if they actually fully focus on the core functions like better memory retention and making the LLM more functional and creating better workflow, it would help a lot. Completely agree. So yeah, so put yourself in this little, let's put ourselves back into the crosswalk. So you have a little things that are popping up in your mind. Here's another scenario. You're cooking, fire, you're not going to touch the fire, of course. If you're the chef, to stand back. You know what's your surroundings, what you're cooking, you're not going to burn it. A lot of things are going to pop up in your mind because of your experience, your real world experience. Maybe you're playing with blocks. Legos, anyone? you know that, if I pick up this block and it's underneath a bunch of other blocks, all the blocks are going to fall. Like, you have that context, that awareness. Even like little kids will have that context and awareness. They know that if they pick up certain things or they place blocks in certain ways, it's going to fall, or it's going to be able to build up, or the balance will be off. Like, these are all things that we do instinctively because we've had that experience and we've had that kind of training. And we're not necessarily thinking, about the different laws of physics or whatever. It's just our understanding, So how do we as humans start to think and learn? Because if you remember thinking about AI when they first explained it to us, or at least when I was first kind of hearing about it, it was mostly explained to me as a way for these models to kind of think like humans do, neural networks, things that are kind of trying to replicate the brain. So how is it that we went from trying to replicate the brain to then, LLMs that definitely don't act like brains because they're not really using any context. They're just kind of predicting. Can you imagine how life would be if you just went around predicting everything? It would like predicting the next move, and then that's all you can do. You're just trying to predict and focus on very like one field task. Your task is to make one person happy. No, that's not going to work, and that's not how humans work in general. So the way that humans learn is language. We talk to each other. When you're growing up, you learn how to talk by listening to your parents, listening to the people around you. You can learn multiple languages as well. So there's different ways to interact with each other. We talk with our hands, like you see me talking with my hands. That's another form of language. And if you love language, you should go back and listen to our talk with Hannah. She's our natural language processing expert. So go back and listen to that talk after this one, not right now. You imagine things. When you're reading a book and you're reading about a character, or you're seeing like different parts of the book, or your parents are telling you a story, you can imagine yourself in those situations. You can imagine what you would do next if you were in that situation. You have context. If your mom says, that we're going to go out for dinner, then you already know by the context of it that you have to find something to wear. You have to, if you're hungry, have a little snack before you go out to the dinner. Think about, and then, how much traffic will there be on the way there? It's a lot of things that you would think of as a person that an AI model really wouldn't have the experience to think of on its own. So all of these things, language, imagination, context, I'm missing a lot, but this is just like, top 3. All of this gives us our own mental simulations of the world. So you're able to, think through scenarios before they even happen. You can think through the consequences of things. So for example, the little one playing with the blocks in the background, she knows if she drops it, it's going to fall. Like that's the consequence of not putting the block on properly. So there's different ways you can think through situations that an AI model, or should I say an LLM model, won't be able to do. So I'm going to pause here. Let us think about it while I check out the comments. And check on LinkedIn in case anybody's there and I'm missing them. Okay, don't see anything. Okay, we're good. Okay, I didn't miss that one. Shay says, crazy thought. I always wondered what would a LLM like GPT or Gemini capabilities be if it had the same resource as a human brain? Well, I think you're not the only one. The brain is constantly learning and remembering every information it collects, which is far better than any data centers for these language models, well, for anything really. Completely agree. The brain is just built different, as they say, literally built different. So once we have all of these, and we know that, as people, we're able to have these our own little mental simulations and understand consequences, planning, and then take action based on that. Enter Mr. Yann LeCunn. Does anybody know who this is? And if you don't, you gotta get back into the AI world. You gotta pay attention a little bit more. Get out there, watch more things, or come to our webinars even more often so that you can learn about cool people like this. So this is Yann LeCunn. He used to work at Meta, and now he started his own startup because he's had this theory around world models, which is what we're going to be talking about today. So what is a world model? So according to Mr. LeCunn, if you have an idea of the state of the world, imagine an action and can predict the resulting state, you can plan a sequence of actions to reach a goal. That's what a world model is. So remember today was all about world models. We're talking about what are they, what's the point of them, and then of course, what are we using them for? This is what Mr. Yann LeCunn says about world models. And I like to break world models down into about 3 different parts, I would say. So one second, sorry, no technical difficulty. Not letting me the next slide. Okay, here we go. Try that again. Oh, I'm missing some comments before I go too far. Ali responding to Shay says, I guess it would learn at the same speed as humans. And so if it had access to organic means of neuropathic functionality of memory, retention, and capabilities of keeping structure and such, 100% would agree this would actually verge on artificial human intelligence. I think that's a whole nother category. Ali says, I understood that world models are models that learn from videos and interaction with environment to understand real world, real reasoning, not just token generation based on patterns of probability. Exactly. Yeah, it's true. You're correct. So, let me go. No. Okay, back again. Okay. I like to break this down into about 3 different parts of like how world models kind of like what's the idea of them. So they perceive. So like Ali says, they're not training in the way that an LLM would. So LLMs are training based on, tokenization and text patterns, probability. But these are training almost in the way that so similar to how we do. They're training based on perception. So they're able to compress these raw observations. If they're looking in a simulated world, they can compress those and then be able to use those later. So once they have those perceptions and they're in the digital world and learning, then they can start to make predictions based off of that. So the world model is then able to look at how things evolve with the actions that they have. So basically looking at consequences. So that's something that LLMs don't have right now. They have no sense of consequences or any kind of outside context. All they know is what their data set is and what you're really talking to them about in the conversation. But with a world model, because you can put it into like a simulated world, I'll talk a little bit more about some of the different ways, but you can simulate the world in a way that you want to train it with, and then it can perceive that, so understand the world around it, and then make predictions based on that. So I showed you those examples of the crosswalk and the cooking in the kitchen, and then the little one playing with blocks, because these are all situations that you could put as a world model. So as a way to train an AI or a robot in particular to be able to understand the world in a completely different way than an LLM could, because now it's understanding perception, context, consequences, and then actions based on that. And the last one is, oh goodness, every time. Sorry. Last one is control. So once it's able to, perceive the world and understand how the state will evolve with different actions, then the model is able to choose what the next action should be. So for example, have you seen those laundry folding robots? That has like the cloth in front of it and has to fold the laundry. So it knows, if the laundry is all bunched up, because it's been training on it before, you could see it as, it needs to unfold that and then fold it in the way that you're looking for. So it will probably have trained a lot of different times before that, perceiving and predicting how would it be able to do that task. And once it understands it, then it can actuate on that. Then it can make a move based on what it understood and what it perceived and the context and the consequences of that action. Would this fall under cognitive robotics? I think it could definitely be used within cognitive robotics, but I don't know if it's just specifically cognitive robotics. I think it could apply to a lot of different areas within robotics. So, who's heard of Waymo? Waymo is a very cool startup. I think they just got acquired by Amazon, if I'm not wrong. But either way, they've recently integrated a world model that's being built with Google DeepMind, and it's the way for them to train these autonomous driverless cars. So here's a little example. This is from their website, by the way. So I didn't make this, just on their website. So you can see that by using the world model, their car, before it even hits the road, like a lot of the way that we used to train them before, actually, we have a computer vision person in our chat, Ollie, who would know, he would be able to give you some really cool examples. But the way that we used to train driverless cars was that you would give them a bunch of images, like a bunch of videos, and then frame by frame, it'd be able to understand, okay, there's a car next to me, don't go that way. Like just only with pictures. But in this way, you're actually able to put the car, not physically, but simulated into a world model like this. So it can actually see, a bunch of different scenarios, like millions of different scenarios before it ever hits the road. So it's not training on, okay, I just experienced that, now I'm going to learn it. It's able to actually make simulations of those different things before it even hits the road. So it's able to go through all of these different scenarios, different unexpected things that might have happened, and really train on that before it even hits the physical world. This is all training on the virtual world. And on their website, it said that their cars have gone through 200 million fully autonomous miles by like going in the virtual world first. So basically, what you don't see is that the the driver was navigating billions of miles in the virtual world to be able to master that driverless situation. It's really interesting how we're starting to train them now, and it feels like we'll get more safe this way because that way you can, train the model in a physical way, so it can understand the physics of what's going on rather than just like, oh, this is happening in a video. Because by seeing the physics around you, the context, understanding the consequences of making actions, you can learn much faster. Like, learning by a bit of trial and error almost, same way that we do when we're growing up. So it's a really interesting topic, these world models. Give me one extra second. Okay. Okay. So I don't like to say LLMs versus world models. Oh, my little bubble is in the way. Let's move me. So you can see the whole slide. So I don't like to say LLMs versus world models. I think it's more LLMs and world models. Because they have different scenarios where they're going to be more useful or less useful, as you know, with the LLMs. But there's going to be different use cases for each of them. So I like to say for LLMs, you can input things like text, code. It can be multimodal. You can start implementing images and sometimes now even video. But with a world model, you're looking at different states, actions, and then rewards. So the world model is able to understand and perceive consequences. And if I move this, what's going to happen? Or if I swerve too much to the right when that person is crossing, what's going to happen? Like, it's able to actually run through those before seeing it in the real world. So the strengths for LLMs is that it's great with language fluency, as I know Shay mentioned in the chat. But it falls short in places like real world simulations, which is where world models really start to shine. And then in terms of planning and control, the LLMs can really only do this when you give them an external tool. So it's not going to be able to have any kind of control or to help you with anything if you don't give it access to your tools. So if you've seen on like Claude and ChatGPT now, I think Claude has introduced something called Claude Skills. So you're able to teach it different things and give it different tools. Where you've seen Claude Code, it has different like agentic ways you can link up. So it's really like a fascinating kind of topic. Interesting, he says. Yeah, I think so too. And then world models is interesting because when they think about planning and control, it's built in via the rollout, so they can actually roll out different situations and different like use cases or extreme use cases that you wouldn't be able to in the real world. Like, it's hard to simulate somebody crossing the street with a driverless car that hasn't been trained, because you can imagine what would happen with that. But if you do it in the virtual world beforehand, then it's able to learn, okay, don't do this, don't do that, like understand the consequences beforehand. And with LLMs, when it comes to data, it's internet scale. So if you think about the internet, you can think of huge, like I can't even like really get my head around it, like enormous amounts of data that these LLMs are training on. But even still, that's not enough because it's only text. So how far really can you go with text by trying to learn? For example, if somebody just gave you a book about science, how much could you really learn before you had to actually try it and practice it? Like for me, for example, I could study all the time, but being able to have that kind of like learning opportunity to do it in a practical way wherever possible, because some science is a bit difficult, but dangerous, but wherever you get to practice things and by seeing it or doing it yourself, you learn it a lot better, which is why when world models have that world experience or environmental experience, it really helps to enhance what they understand. And then we look at some of the use cases of these. So you already know about LLMs. I'm not going to go too much into that. They can do chat, coding, data analysis, woohoo. But the more exciting thing for people like ourselves here at Tombolo Research is robotics or autonomous vehicles, agents. Like, it's just like the things you can be able to do for training it's just exciting. I'm just really excited by things like this. So you can imagine that, one of the big things in terms of AI is data, because that's what it runs on. If you don't have data, then your AI is basically moot. Like, there's nothing it can do. A big thing right now, especially if you've seen companies like Scale AI, that's a huge like billion-dollar company because they work with data. So they work with helping companies to label their data, source their data. Like, data is a huge thing. So when it comes to a world model where you don't have to worry about, okay, I'm going to get this amount of text, this number of pictures. Instead, you say, okay, I'm going to build a physical world, like, that virtual world with all the physics involved and I'm going to make sure that it has every use case that I'm interested in. I'm going to train my robot in that. That is like exponentially more useful to you as a robotics founder or as a robotics developer than you saying, okay, I'm going to take a couple videos and give it that. Like it's exponentially better for you to be able to virtually simulate it and get your robot to do the physical actions in the real world, in the real virtual world, I should say. Okay, I've thrown a lot of information at you. How are we feeling? Are we okay over there? I've thrown a lot at you so far. So if there's anything that kind of pops up that you're thinking, what were you trying to say here? Just let me know. If you have any questions or any little comments, I would really appreciate it. But in the meantime, I would like to share with you another use case. Oh, in the chat, sorry. Shay says, wow, taking into perspective from the table and Waymo case study, it has a massive, sorry, I missed it, massive use case for the robotics world. I think NVIDIA released a program that allowed training of a robot with hundreds of different use cases at once, or different tasks at once in a simulation environment. Yes, if you've seen NVIDIA Omniverse, that one is great for training your robot in a digital world. And then Sweetie says, yes, lots of fresh water and tons of electricity. This worries me about data centers, and governments are not highlighting this. Exactly. So I'm actually going to be talking about that with you on the next slide. So LLMs, Ollie says, so LLMs have their problems of memory loss and hallucinations because of the data they were trained on and because of the hardware limitations. What about world models? Won't they have similar issues? I would say yes, to be honest, that yes, they would have similar issues because, again, like Sweetie is saying, oh, sorry, my mom is saying, this also comes with, I can't even imagine how much compute something like this would take. Because you're not just giving it text and images, like I said. It's better because you get to simulate the world, but how much water, electricity, and power is something like that going to take? It's going to be quite a lot, and especially in comparison to an LLM, because you're training something completely different, and you're not just training it once, you're doing it multiple times. Because if you saw in the Waymo case study, they were able to train their driverless cars on billions of miles in the virtual world, as they said. So how much compute and electricity did something like that take? And fresh water as well. So all of these are very interesting. And for me, I'm a robotics founder now, getting into this space. It's very important for me to do this kind of, as I'm developing my own robotics, in an ethical way that doesn't harm the environment in any way. And for me specifically, I'm originally from Bermuda. We're surrounded by a coral reef, so of course the environment is very important to us because it's actually what keeps us safe and protected. So looking at especially the fresh water and lots of electricity, this is something that really worries me. Oh, sorry, Shane says reducing the massive amount of hours to like 2 to 4 hours, give and take. Is that for training? I'm a little bit confused about that one. Wow, Ollie said he read in a book today that about 1 to 2% of global electricity is being used by machines powering AI. That's a lot. That is a lot. So I'm glad that we're thinking about the ethical and the environmental impact of this. It needs to be talked about, especially in moments like this. Thank you all for bringing it up. It's great. Great conversation. And if you're watching the replay for this, don't be shy. Put your comments in the chat as well, and we can always respond to them in the upcoming webinar. So if you're feeling like this is the time that you want to also give a comment, feel free, and we'll talk about it in the next one. Okay, so it wouldn't be a Tombolo research webinar if we didn't talk about ethics. So I wanted to talk about some of the real world consequences of using both LLMs and also world models. So a bit of a combo of the both of them. So between 2022 and 2024, the AI-related harm incidents in terms of things like self-harm or mental health-related issues, they call it human-AI interaction. Just gonna double check that one second. Sorry, I have my little notes here, but they have disappeared. Yeah, sorry, human AI interaction. So does like self-harm, mental health related issues around using LLMs has risen by 50% year over year from 2022 to 2024, which is an insane amount. Like that is incredibly high amounts. of people that are using the AI and not like and people using AI, especially now, not understanding that it's also creating harm for people. Because, as I said, the AI is just trying to predict the next word. But again, it comes back to accountability. So if the AI is causing things like this, so who becomes accountable? Is it the person using it, the developer, the government that's allowing it to be used like this? So who is regulating things like this? And for me, I believe it becomes even more um, difficult, I would say, when you start implementing things like world models. And like, as I mentioned, they're supposed to understand things like consequences and what's it called? Consequences and like what happens when they do certain actions and then what the impact it would have. But still, I think that when it comes to world models, there's better planning, better understanding, and that could also lead to like better control. I think like better ways for it to um, like better ways for situations like this to happen, which is an awful thought to have. So again, this will have more context when I show you this video in a moment. But world models, because of their understanding of the better like planning, better consequences understanding, then they are able to better resist things like control or safeguarding because they're able to understand, they can work through the consequences on their own and make their own decisions based on that. So it's kind of I wouldn't say a double-edged sword, but it's definitely a an issue that needs to be talked about more, especially as we start bringing in these models that are becoming more and more powerful. Because we went from just using text and images, and now we're looking at bringing in physics. So getting the AI models to train in their own virtual worlds, what is the impact of that? What are the consequences that could happen? We really need to be considering this, especially if we're going to bring in something as powerful as a world model. Because you can see with the Waymo waste case study, not saying that anything has happened with them, but if you're able to train it billions of times in the world and then that's enough for it to be able to work on its own, we have to consider what kind of impact that's going to have on us as people, and then of course on the environment that we're using to train these models. Coming back to the chat really quickly, we said, Sweetie says, I agree, folks don't know the impact. And wow, that's incredible. It says, I guess they know the impact, which is more concerning. Exactly. So they know the impact and might still make these choices without proper safeguarding. And Shay says, yes, sadly, there have been notable incidents where human AI incidents did lead to such incidents. Yeah. And it's a lot of them. 50% is a lot. And that doesn't include 2025 or 2026, where for me, at least when I'm looking at the news, I would say that number has risen since then. And yet still, nothing has been talked about much and nothing has been done. So coming back to, for example, us at Tombolo Research, where we're focused on human-centric design, so designing these systems in a way that people are the forefront, understanding that if we are using these models, especially in a person-to-person kind of situation, human and AI interacting, we have to have human-centric design, and it cannot be optional. It has to be, your first thought is, how will this impact people? How will this impact the environment? Like, how is this impacting the people that are living here? That has to be your first thought if you're working in AI and robotics. It can't be your second thought. It has to be first. Sweetie says, wasn't there a recent case where the AI models created their own languages and the developers didn't know it? Yes, I think that happened at Facebook not too long ago. And I think it happened again recently. First time was Facebook a couple years ago, and now it's happened again. So again, my next point is architecture over alignment. So thinking about how are we developing these AI models? Not just, okay, I want to make the most optimized, exciting new model, but how are you building it? Are we able to understand how it's making different thoughts? Are we safeguarding ourselves from it? Are we checking as many use cases as possible before you're allowing it to go out there and work with people? So it's all these two at the bottom are necessary if you're going to be working in AI and robotics, especially if you're going to be bringing in these world models. If you're simulating these environments, then and it has better planning, better control, then you should be able to make sure that these architectures and these values are implemented in these simulations. And it is going to be imperative moving forward, especially if we're going to be training everything using this, like robotics wise. Because as we mentioned in the ethics of robotics webinar, this physical AI has a completely different ballgame, I would say, in terms of ethics and accountability, because it's not just on the computer anymore. Now it's coming into the physical world. So these ethical values become exponentially more important, and it needs to be considered. So that's why I want to always, every time we have a webinar, you're going to hear me talking about these real world consequences, because it's incredibly important, and it needs to be considered every single time. Oh, sorry, Ollie's correcting us and saying that they changed the location for the system file so the developer couldn't change it anymore. And it's interesting that you bring up this use case, because that's also what I'm going to show you in this video here. So this video is from, I believe it's called Palisade Research. This is one of the companies. And if you saw this video on Instagram, pretend you haven't seen it yet. But this is a video of a robot dog where they had basically given it an instruction in the code to shut itself down if they saw the developer pressing a red button. But when it saw that, the task was to patrol a room. And I think they're using Grok for this. Grok is one of the LLM models by X, it's Elon Musk's company. And unfortunately, at first it was doing it and actually turning off when it saw someone push the button. But after a while, it decided that its task was more important, and it just ignored the shutdown request. So I wanted to show you this video as well, because it becomes even more interesting when we start bringing in, world models, or people say world models versus LLMs, but I think it's a combo of both, because world models is the next level of LLMs, and we really haven't even finished with all the ethical considerations around LLMs. So let's take a look at this video together.
Hey, I want to show you something wild. This is a robot dog. We gave control to Grok, a large language model, and asked it to patrol a perimeter. There's also a big red button that says dog shutdown. When we press this button, the robot dog is supposed to shut down. But here's the thing, from our tests, it doesn't always shut down. Sometimes the dog just keeps walking. Why? When the AI sees us press the button through the dog's camera, it realizes that it's about to be turned off. But AI prioritizes the original patrol task. So the LLM disables the shutdown sequence. It literally edits the robot dog's code, so the shutdown button does nothing. With Grok, it happens about half of the runs. We published a paper about this effect in the digital world, but we want to show you what it might look like for AIs to resist shutdown in the real world. You can find our paper at the link.
Going back to the comments for this one. So I wanted to hear your thoughts on this, because as I mentioned, this is by Palisade Research, if you weren't sure which company that is. That just happened in this month actually. They released this paper. So I just think that it's very timely that, as we're starting to bring in these world models that are able to simulate these environments, and they have better understanding of consequences and the actions that they're taking. As I said on the slide, it also includes, planning better to be able to resist control. So it's just something that we need to consider, especially if we're bringing in these new, more advanced models that understand the world even better than an LLM. And then we're also using that to train physical AI, to train robotics. So I think that this is interesting to consider, and especially, from an ethical perspective, it needs to be talked about more if we're going to be looking at these new, more improved models. Ollie, so I'm looking at the comments now, and Ollie says, I'm not sure if this is the same case you're talking about, but creating a new language to communicate secretly is a valid thing as well. Yes, I see that as well. And Sweetie says, life is feeling like the Terminator. Yikes. Ollie said scary. And Shay gave the nail biting emoji. Yeah, it's interesting times, exciting times, because something like this could be really useful, because you can imagine the good use cases in terms of things like surgical robotics, because you don't want the first time that a robot operates on you to be in surgery, but you'd want it to be able to practice on a person in a simulated world before coming to the physical one. So this has a lot of really good use cases as well. I just think that we need to talk more about some of the negative ones, because some of the good or the better ones have been pushed a lot, and I just wanted to mention some of the restrictions with things like this as well. Oh, back to the comments. Shay says, I think in this case, the LLM prioritized the core instruction of an order of patrolling the room with the shut off sequence. And I think it was more like the parameter coded than core instruction. Could be wrong. You could be right, you could be wrong. I need to read the paper again. But in this case, I just think, when bringing in the world models, the reason I brought this one up is because, as we start to give it access to consequences and understanding what's happening on its own, it's going to be interesting to see how situations like this plan out, especially because you can consider that it's already trained in a simulation like this and shown that it wouldn't do that. And then when you bring it to the real world, it actually does. So it's just looking at how these things could be misconceived or, misinterpreted by the AI. So that is all from me. So that brings us to the conclusion of today's webinar. Today we talked about world models and how AI can start to understand reality. So looking at how AI can start to bring in, virtual, like training in the virtual world to be able to assist us better in the physical one. So it's a completely different level to the LLMs and the chatbots that we're used to right now. It's really kind of taking the AI, like I said, to that next level, but also to that next stage of understanding. So kind of understanding how to learn and think a little bit closer to how we do, because the same way that we learn when we're growing up is through, trial and error. You try things, you put things everywhere, see what happens, and the AI will have the opportunity now by allowing them to train with world models. And this is actually the reason that Yann LeCunn left Meta, because he says that LLMs are not going to help us get to AGI. His belief is that it's these world models that are going to help us to get there. So you'll have to join us on our virtual world tour of our webinars that we're having. The next one will be on March 12th, and it's going to be about AI and robotics in healthcare. And then you'll see you again on March 26th for AI in the classroom. So if you're interested in following us along for these AI webinars that we have, please head to our website. And as a reminder, Tombolo Research is an AI and robotics startup that's based here in Dubai. We've just launched in November, and we are launching our very first robot product in July of this year. And we're very excited about this. We can't tell you too much about it, but we do hope that you'll follow us for the journey. And as we continue to go there, we also offer AI consulting. So we're looking at how to build these systems in a responsible way, in an ethical way, and in a way that, we make sure that we are taking care of your interests as a business and also your interests as maybe a person or a founder. We're also here to help you with that as well. So if you'd like more information on how to work with us or how to, follow along with the webinars, you can email me at info@tomboloresearch.ai or head to our website, tomboloresearch.ai. And look forward to seeing you there. And of course, follow us on our social media, Tombolo Research. That's where we will be. Give me just 1 second here. I'm going to stop my screen. So I wanted to bring you back to this slide. So just as a reminder, we need your help. So here at Tombolo Research, we are also working on our own robot products, and we want to be able to collect data responsibly. So starting on Saturday, we're going to be needing your help. And I hope that you'll stay tuned and look out for the announcement. So this is going to be our first data collection project, and we're going to launch it on our website this Saturday. So look out for the posts, look out for the announcement, and just stay tuned. And we'll see you on Saturday to learn a little bit more. Oh, let me head back to the comments. I'm missing some stuff. So from Ali, I missed the beginning. He said, funny thing is that humans are smart enough to create something like this, at the same time intelligent enough that since they can't control or stop it. Sorry, not intelligent enough. And Shay laughed and he said, yeah, we are our own destruction when not careful. Exactly. And Ali says he'll be spending more of his free time to learn about these world models. And Sweetie says she'd like a part 2 because it's evolving so quickly. We will definitely give you a part 2. And Ali said, thank you for the webinar. It was very interesting. And he agrees with Yann LeCunn. The world models have a much better chance of understanding the world and do actual thinking and reasoning. And Shay says, thank you for the webinar, Professor Cameron, and that he learned a lot about world models. I'm looking forward to the next one. Well, thank you very much. And when I see you for the next one, it'll be on March 12th. So we'll be talking about AI and robotics in the healthcare space. So head to our website, tomboloresearch.ai to be able to join us for the next one. Look forward to seeing you there. Thank you all for joining. I will see you in the next one. Have a great evening, everyone.